Hey everybody, it's Mr. Carr again. Today we're going to talk about 7-4 logarithmic equations. And a big goal today is how to solve them. So, two types that you'll encounter for a logarithmic equations. That's going to be tough to say a lot. So there's the kind that has a single logarithm. So it just has one log base something of whatever. Okay. When that's the case, when the variable is in the argument, we isolate the log term, then switch it to exponential form and solve. That one's not too bad. If we have multiple logarithms, then what we need to do is we have to write a new equation without the logs, but the arguments are equal to each other and solve. This is only true if the multiple logarithms are the same base. Okay, so that's what we're focusing on here is if we have the same base. So like, for example, log base 4 of x equals log base 4 of 10. What we're saying with this kind of a problem that looks like this is a very basic inversion. The only way for this to be true on both sides is if x equals 10. We just drop the log base 4s. Okay, so let's try these out for the first example. Okay, so 3 times the log base 27 of x plus 3 equals 5. The idea is that I first want to isolate the logarithm. So I'm going to start by subtracting 3 to both sides. So 3 times log base 27 of x equals 2. Not quite isolated yet, so I'm going to divide both sides by 3. So that means log base 27 of x equals 2/3. Okay, from there, remember what this means in their logarithmic form. This is my base, this is my exponent. So we're saying that 27 to the 2/3 power should equal to x. Well, that if we go back to what we did before in previous unit, we know that this is going to be the cube root of 27 to the second power. So cube root of 27 is 3. 3 squared is going to be 9. So that's my answer is 9 for x. Answers should be checked, though. They cannot produce a negative argument. So what I'm saying here is let's pretend for a second that this came out to a -2. You cannot evaluate logarithms and come out with a negative answer like that. So that's not going to actually work because, oh, wait, no. Never mind. You can't come out to a negative argument. So if x were to come out as a negative value, like -9, okay, -9 would not work here. We cannot evaluate log base 27 of a negative number like that because you're saying that 27 raised to some power gives you a negative value, and that's actually not going to happen. Okay, so that's going to be so that's just something to be aware of. So you just do a quick check. Can I evaluate this in the original problem? Yes, you can. So it's good. All right. Here's one where logarithms are on both sides. So log base 4 of x squared equals log base 4 of -6x minus 8. Again, with logarithms on both sides, as long as they're the same base, we can just drop them and turn this into a quadratic. X squared is equal to a -6x minus 8. Okay, well, now it's just solving quadratics like you've done before. I'm going to choose to do this through factoring, but first thing I gotta do is get it equal to 0. So x squared plus 6x plus 8 equals 0. And then I can do that through factoring. It'll be x plus 4, x plus 2. Okay, and I solve those out. I get x plus 4 equals 0, x plus 2 equals 0. So x equals -4, x equals -2. Potentially, I have 2 good answers here, but double check. They must be checked. They cannot produce a negative argument. So this side is fine. Since it's x squared, I would be taking log base 4 of -4 squared, which is going to be the log base 4 of 16. That's fine. Okay, same thing with the -2, log base 4 of -2 squared. So log base 4 of 4. So the left side is fine, but let's double check the right side. Okay, so we'll do this one here. So we'll do log base 4 of -6 times a -4 minus 8. So -6 times -4 is a positive 24. Minus 8 is going to give me 16. All right, so that one's fine. On the right side, we have log base 4 of -6 times a -2 minus 8. Okay, so then I have, that's going to be a positive 12 minus 8 is going to give me 4. Okay, so it checks out on both of them. Okay, so both answers are actually good. If one of them created a negative number in the argument right here, that would be extraneous. So you just cross off that answer. but both of these work out okay on both sides, okay? So we get the same thing, log base 4 of 16, log base 4 of 16, log base 4 of 4, and log base 4 of 4, okay? So both of them are okay here. And that's it for today. We will continue with more solving, make them more complicated, but right now, that's all we're going to focus on. So again, if it's a single logarithm, the goal is to isolate the logarithm and then rewrite it into exponential form, okay? If we have multiple logarithms, as long as they're the same base number, we can just drop that base and then solve what's left, okay? That's it for today. Take care, everybody.